For proving problem, normally we start with a more complicated expression. So in this question, the left hand side of the expression is more complicated. So we start with this first. So left hand side is equal to 1 over. Now when we see cosecant, secant, normally we would like to change it to sine and cosine. So cosecant, it will be 1 over sine, and secant, right, is actually 1 over cosine. Okay, let me simplify this expression here. Is sine theta plus 1 divided by sine theta. Here, maybe I would like to change it to sine over cosine so that I can combine with this expression here. Okay. Now the denominator is the same. We can add up the numerator. For this expression, we can rewrite as 1 plus sine theta multiplied by 1 minus sine theta. And we know that a plus b, a minus b can rewrite as a square minus b square. So this will be a 1 square minus sine square theta. Okay, so this one, the expression that we highlight, can be simplified as 1 square minus sine square theta. 1 square is just 1. Okay, then sine times cosine, we cannot do anything, just leave it. The next expression here, 1 minus sine square. We know that sine square theta plus cosine square theta equal to 1. So 1 minus sine square is actually equal to cosine square theta. Okay, if we bring the sine square over, so cosine square is 1 minus sine square. So 1 minus sine square you can simplify as cosine square. Okay, the square here can cancel with this cosine term. So we will get cosine over sine. And we know that cosine over sine is a cotangent theta. Now, we take a look what we are supposed to prove. We are supposed to prove that the right hand side, we should get a tangent theta. And we know that 1 over cotangent is tangent, which is equal to the right hand side. Okay, proof. For question 6 part 2, we are supposed to find the angle theta that satisfies this equation here. And we know that this expression here from 6 part 1 is actually equal to tangent theta. I would like to combine these two terms together as one. So either I change the tangent theta to cotangent or change the cotangent to tangent theta. And I think we are more familiar with tangent theta. So we'll just change the cotangent theta here to tangent theta. So cotangent is 1 over tangent. You bring a tangent theta over, it will give you a tangent theta whole thing square. Okay, so another way of writing this is of course tangent square theta. Okay, you should be familiar with either this writing or this writing. So our aim again is to find the angle theta here. So we bring the square over, it will be a square root of 3 or negative square root of 3. Now the question only require us to find the acute angle theta, the acute angle theta. So for acute, okay, acute angle lie in the first quadrant. So we just need to consider the positive tangent theta. Okay, so this one is not applicable because in order for tangent theta to be negative, it has to lie on here and here, and these two quadrant, right, is not acute angles. Okay, acute angle will be the first quadrant here. Okay, so the first quadrant tangent theta is positive. That's why we choose this expression here. So theta will be equal to tangent inverse square root 3. Now the question requires us to express the answer in terms of radian. So if you want to get the answer from the calculator, make sure your calculator is in radian mode. Okay, or if you can remember, this tangent inverse square root 3 is actually a special angle, which is 60 degree. 60 degree is actually equal to pi over 3 radian. Okay, this is the answer.